All right, so I'm gonna adjust my screen so that I can see both the simulator and my lab document at the same time, right next to each other. I highly recommend doing this if you can. I know that some of you are working on very small Chromebooks, and so it's not necessarily that easy to do. But the most that you can do to be able to quickly see both of these things, the easier it will be, okay? I'm going to start filling out part 1 with you, but then part 2 is going to be up to you, all right? So to reset my simulator, which if you have not opened the website yet, the link is right here on the actual lab document. So what we're going to do is we're still on the intro tab. So if you need to move back to it, you can click the little home icon here and click intro. And I'm just going to reset my chamber. To reset it, you click this little orange arrow down here at the bottom, and it puts everything back to the default settings, okay? This eraser here just erases your gas particles, and so make sure you click the full reset so that way we're all starting on the same page, okay? And it says record the pressure, temperature, and volume, the width of the container for now, when there are no particles in your chamber. And so what I'm going to do is I'm simply going to look and I'm going to be like, all right, I don't have any gas particles in here and I have a pressure of 0 atmospheres. So I'm going to type 0.0 ATM, which is the abbreviation for atmospheres. And if I look at the temperature, well, our temperature is blank. It literally says blank Kelvin, meaning there is no temperature. Why is there no temperature reading for this gas chamber right now, my friends?
There's no energy in there.
There's no energy because why?
There's no gas particles.
Exactly. Temperature, measure of average kinetic energy, aka how fast or slow particles are moving, but there's no particles. So if there's no particles, there's no movement, okay? And so we're not going to write 0 because 0 means particles that have stopped moving, but you still have to have particles. Here we don't have any particles, so there's no temperature, okay? And then for volume, the one fault in this website, I don't know why it does not tell us the volume of the container. It's very annoying, but what you can do is in the top corner, there is a width button, and it will tell you the length of your container, or the width, I should say, of your container. Okay, and that is going to be representative of the volume. So I just am going to write the width is equal to 10.0 nm, which stands for nanometers, which are very, very, very small units of length. A nanometer is 1 times 10 to the negative 9 meters, or 0.000000001 meters, okay? If you remember our scale of the universe, this is when we started seeing individual atoms and things, okay? And so those are our initial empty container conditions. Fine, who cares? What we are trying to do is to identify the relationship between number of particles and pressure. So what we're going to do is we're just going to keep following the instructions. Give 1 pump of gas and observe the behavior. So I'm going to take my air pump and I'm just going to give it 1 pump. I don't care if it's the red particles. I don't care if the blue particles. The only difference between them are their relative size and masses, which does not impact what we are learning this week. And you'll learn why it doesn't impact it in college and how different gases, you'll learn about partial pressures in college. But for now, just choose one color and go with that, okay? And so what we're going to do is I'm going to record my observations. I'm not going to do that. You're going to record just a quick note of what you saw happen when you added the gas. You're going to record your new pressure, new temperature, and new volume, okay? I'm going to go ahead and give you guys 1 minute to get that filled out. So on your lab, you should be on number 3 and get all 4 of these boxes filled out in the next minute or so. If you need to use my data, fine, but this is really the last thing I'm going to be doing, so make sure you have your simulator open. All right, so what you're going to do now, because most of us looking at this have completed question number 3, is we're basically going to do the same thing, okay? We're going to keep the volume and the temperature constant. So we're not going to change the size of our container by doing this. We're not going to change the temperature of our container by doing this. We're just going to leave those the same. But what we are going to do is change the number of particles, okay? And the ultimate goal is to be able to fill in this blank. As more particles are added, the pressure did what? Okay, so on my document, I'm going to put, for my number of particles, if you click this little plus sign next to the particles button, it will actually tell you how many I have. So for me, I'm starting off with 50 particles, and I have a pressure of 5.8 atmospheres. Then you're going to change the number of particles and see what happens to the pressure. And there are 3 ways you can change it. Number 1, you can open your container to let some particles leave. That kind of messes some stuff up, but you can do that. You can use the air pump to pump in more particles. Or you can also use these arrows here, okay? The small arrow will remove or add 1 particle at a time, and the double arrows goes in 50s, okay? So you get to choose however many you want and just record your data, okay? So my next data point here would be 124 particles and a pressure of 23.5. And I'm going to keep changing my number of particles. It's easiest if you just keep adding and see what happens to our pressure. Okay, so I'm going to give you guys about 2-3 minutes to get this data table filled out with the ultimate goal of completing this statement here. And if you finish this before we move on, feel free to move on to part 2 on your own. Just read the instructions very carefully, okay?
What do you do with the volume, Miss?
To get the volume, if you click at the top right here where it says width, it will tell you the size of your container down here on the bottom. So the default is 10.0 nanometers. Okay, and that's this button right here. All right, so for those of us who are using our time productively and not wasting Miss Garcia's time, we're gonna move on to part 2, okay? Now, part 1 is great. As we added particles, you guys all should have noticed that the pressure goes up and up and up. You can see that here with every pump of gas I put, I get a higher pressure reading, okay? But now there's actually a couple of issues with this experiment, okay? Number 1, if I try to remove particles, yes, my pressure goes down, but my temperature also starts changing. And that means this is not a controlled experiment because we have added an additional variable into the system, which is temperature. And so what we're going to do for part 2, which are going to be the main parts of this lab, is using what we've learned about this website, using what we've learned about how to identify relationships using 2 variables, we're going to try and identify what are called the 3 gas laws, which means that as pressure does this, we can predict what volume and temperature are going to do. If volume changes, we can predict what pressure and temperature are going to do, so on and so forth. But to do that, we have to create a system where the other 2 variables, one of them being the number of particles, has to remain constant, okay? And so what we're going to see is that by the end of class this week and the beginning of next week, there are 3 gas laws, one main one called the combined gas law, and a law in science is something that can be represented by a mathematical expression to explain a physical phenomenon. And so one of those physical phenomena we just saw is that as we add particles, the pressure increases. Real world, blow up a balloon. Every time you blow into it, you're adding more particles. And if you add too many, eventually it will pop, okay? I don't think this lab scenario is set up to where it will pop, where the pressure gets high enough to where it will pop just by adding particles. Because I think the max is 1,000 of each. And if I make it smaller, it might explode. But that's adding a new variable with volume, okay? And so what we're going to do in part 2 is actually use the laws feature, okay? So if you go back to the home screen, instead of intro, we're going to use the laws one because this situation allows us to set certain things as constant, okay? And so you'll see in the instructions that we're going to keep the number of particles constant throughout this entire experiment. So we're not going to keep pumping in gas or removing in gas. We're going to keep a set amount from the very beginning. So experiment 1, volume, we're keeping volume constant. Step 1, give 1 pump of gas into the chamber. I don't care if you use red or if you use blue, but just choose one of them and give me 1 pump, okay? Then it says hold the volume constant by selecting that option in the upper right hand corner. So anytime I have you change the settings, I will have a picture on your worksheet where you can see what I'm talking about. So for this one, I'm going to keep the volume constant, and you'll notice that little handle goes away, so we can't make the container bigger or smaller. And so from here, we're going to record the initial temperature, which for mine is 300 Kelvin. I believe most of yours will also be 300 Kelvin. That's like the default temperature of this setup. And the pressure is going to be 5.8 atmospheres. And so what we're going to be doing is we're going to be manipulating one of these values, aka our independent variable, and see what happens to the other, aka our dependent variable. So what you are going to do right now, because I'm not going to go through the whole thing with you because then that would be boring. It wouldn't like be you actually exploring. Oops, spoiler alert. Is you are going to keep following the directions. Use the slider at the bottom of the simulator to add heat and double the temperature. So this guy right here, you can either raise the temperature or lower the temperature, but this says to add heat to double. So I'm going to heat it up until about 600 Kelvin. If you can't get it exact, that is okay. It's not the easiest thing to get perfect. I've been able to do it in almost all of my classes. But now it looks like we're going to hang at 601, which is fine. There we go, 600. I have a mouse, so it might not be as easy with a trackpad. And you're going to just answer some questions. Did the pressure go up and down, up or down? What is the new pressure of this chamber? And from here, you are going to not only record data like we did in the last one, but more importantly, you are going to graph it. Okay, and so in about 7 minutes, I'm going to go walk through how you can use the online graphing calculator Desmos to graph your data. Or if you prefer, as the instructions say, you can draw your graph and take a picture, upload it. You can use Google Sheets as we have done in the past labs. Or at about 2:09, I'm going to go through how you can use Desmos to actually graph your data. Independent is what I change, and dependent is what changes as a result. All right, my friends, as promised, it is 2:09, and so we have 2 more things that we're going to do before we skedaddle. Number 1, if you have been using time in class, you are almost done with this lab. You just need to make a graph, okay? And so what you're going to do to make your graph, you can do anything that you want, okay? You can draw it on paper, upload a picture. You can copy this data table into Google Sheets. You can actually insert a chart directly from Sheets here, like you can make it from scratch. Whatever you need to do, you can do that. Or what most students are preferring to do is to use the Desmos graphing calculator. And some students are familiar with it, some students are not. So I'm going to actually just walk through how to do it right now. So I'm just going to make a random graph right now, but the process will be the same, okay? You can either Google Desmos graphing, or I did post a link to it in the original assignment on Google Classroom. And usually you guys are probably used to doing this to make like a graph, okay? Y equals x squared, whatever. But you can also just add a data table. You click the plus sign at the top and then click table. And now you have your x values and your y values. Life hack for scientists, independent variable is always x, dependent variable is always y. So I'm just going to put some random numbers right now. They don't mean anything. I'm just showing you how it works. This would be our graph, okay? Now, if it's big numbers, you might not be able to see everything. So if you click this little magnifying glass right here, it will actually zoom out and show you your whole beautiful, pretty graph, okay? And the default is to just make a scatter plot, but some students actually prefer to connect the lines. And kudos to Naomi, she figured this out yesterday in my section 12. if you click and hold this like green cookie thing, just click and hold, your options show up. And so you can actually turn it into a line. Okay, you can change the color, you can make the X's, you can do whatever you want to do to make your graph look cool. Okay, and so once you have your graph, I recommend just taking a screenshot, which is going to be different on different computers. So if you need help figuring out how to do yours, I can help you out. And then simply just add it to your worksheet. Okay, and so then you have this, and I like to click this middle option because then it just sets it in with my text and it looks nice and it's cute and whatever. Or you can upload it as a separate attachment on Google Classroom. Whatever works for you, okay? Yes, Liz, everybody's graph is gonna have the same general shape because the relationship is going to be the same for everybody between temperature and pressure, but your individual data points will probably be different because everybody has different temperatures and pressures, okay? Okay, and you can answer this question at the bottom or you can wait for it for tomorrow. Either one is fine. And that is all you have to do, okay? If you've been working through class productively today, you're good to go. Tomorrow, we are going to be assigned an asynchronous experiment. So it's going to be one more of these, and it's going to be the relationship between pressure and volume. So if you look on over at your Zoom call, I posted a poll question where you can make a hypothesis for what you think the results are going to be for our experiment tomorrow, which you should be doing on your own time tomorrow during class. But if you are not staying around, that is all I have for you today. You are welcome to leave the Zoom call. I hope that you used this time productively and you got your day one for the lab done because there's going to be 3 days for this lab this week. And so, yeah, okay. So if you're leaving, I hope you all have a great day. I will see you all on Thursday. Good work today, my friends.